Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, and in today's lecture, our topic for today's lecture is atoms and atomic structure. So looking at the objectives before us, we'll be defining atoms. Then we're going to talk about, the fundamental particles of atoms, which are the subatomic particles. So we're going to identify and describe protons, neutrons, and electrons in terms of their relative charges and their relative masses. Then we're going to talk about atomic number, mass number, number of proton, and number of neutron. Then we'll be describing the distribution of mass and charge within an atom. Then we'll talk about the behavior of the fundamental particles of an atom, which are protons, neutrons, and electrons in an electric field. Then we're going to determine what, the number of proton, the number of neutron, the number of electron in both atoms, and what ions. So please, I want us to listen attentively and get the best out of today's lecture. So we are looking at atom and atomic structure. So what is an atom? An atom is the smallest particle of an element that takes part in a chemical reaction. Chemical reaction takes place every day. In our daily activities, chemical reaction takes place. For example, when iron is exposed to moisture and air, it undergoes what? Rusting. That is a chemical reaction. An ion is an element, and the component of the air that ion is exposed to is what? Oxygen. So when we talk about element, element are substance that are found around us in nature. Like the air we take in is made up of so many elements. That oxygen is a component of the air. Oxygen is an element. Nitrogen is a component of the air. Nitrogen is an element. Argon is a component of the air. They are all what? Elements. Even in our kitchen, most of the things we use, like the spoon, plates, and pots, they are made of what? Iron or aluminium. They are all what? Elements. So an atom is the smallest particle of an element that can take part in a chemical reaction. So when we talk about elements, these are things that are found around all that we make use of. So there's nothing strange about what? The word element. So it's the smallest particle of an element that can take part in what? In a chemical reaction. We can also define atoms as the smallest particle of matter that we cannot break down further by chemical reaction. What is matter? Matter is anything that has mass and occupy space. The air we breathe is an example of matter. The water we drink is an example of what? Matter. The chair you are sitting down is an example of matter. Even you yourself, is an example of what? Matter. So atoms are the smallest particles of matter that we cannot break down further by chemical means. So every atom has nearly all of its mass concentrated in a tiny region in the center of the atom called what? Called the nucleus. Now if you look at the atomic structure, there's a part that is called what? Called the nucleus. So the mass of an atom is concentrated what? In the nucleus of that atom. So we're going to dissect the nucleus of an atom. We're going to look at the components of the nucleus of an atom. We're going to look at the composition of the nucleus of an atom. We're going to look at what is inside the nucleus of an atom. That is where the mass of an atom is concentrated. So an atom is the smallest particle of an element that can take part in the chemical reaction. Or an atom can be defined as the smallest particle of matter that we cannot break down further by chemical means. So we are looking at the nucleus of an atom, where the mass of an atom is concentrated. So what is the nucleus? So the nucleus is the central part of an atom, and it's composed of protons and neutrons. That means the protons and the neutrons are concentrated in the nucleus of an atom, and it contains most of an atom's mass. Yes, the mass of an atom are concentrated in the nucleus of that atom. So outside the nucleus, particles called electrons move around in regions of space called what? Orbitals. So this is just a description of the atomic structure. So the atomic structure, which is the atomic structure, consists of the nucleus, where the protons and the neutrons are concentrated. where most of what its mass is what concentrated. Then outside the nucleus, particles called electrons move around in a region of space called what? Orbitals. That's how we say an orbital is a space or region where one is likely to find what? Find an electron. So what are the subatomic particles? We want to look at the subatomic particles and their properties. We want to look at the subatomic particles and their what? Properties. The first one is, what is a proton? Proton is a subatomic what? Particle. It's one of the fundamental particles of an atom. So what is a proton? A proton is what? A positively charged particle found within an atom what? Nucleus. So the proton is located inside what? The nucleus of what? Of an atom. Yeah, inside the nucleus of an atom. And it is positively charged. So you can see this is a proton. It is positively what? Positively charged. So please take note of that. A proton is found inside the nucleus of an atom, and it is what? Positively charged. So it's one of the subatomic or subatomic particles that has what? A positive charge and is found within an atom what? Nucleus. So the next one is, what is an electron, which is also a subatomic particle. So I want to look at an electron as a subatomic particle and its properties. Now an electron, what is an electron? Electron is a negatively charged particle located in the shells that surrounds what? An atom's nucleus. Yes, it's negatively charged and is located around what? The shells, in the shells that surround an atom what? An atom nucleus. So please, I want us to take note of that. It's one of the fundamental particles of an atom. It's a subatomic particle and it is positively charged and is located in the shells that surround what? An atom's what? An atom's nucleus. So the next one is a neutron. So what is a neutron? Which is a subatomic particle. We're going to look at the neutron and its properties. It's one of the fundamental particles of what? An atom. A neutron is uncharged. It's an uncharged particle. That means it has no charge and is found within what? Within the nucleus of an atom. Within the nucleus. So the protons and the neutrons makes up what? The mass of an atom. So we'll talk about the atomic mass. It has to do with the proton and what? And the neutron. But the neutron is what? Is uncharged. So that is it. So looking at the atomic structure, you look at the nucleus, which consists of the protons and what? And the neutron, where the mass of an atom is concentrated. So there you have the proton plus what? The neutron, which is the nucleus of what? An atom. So you can see the electrons revolving around the shell, revolving around these are the electrons. So the protons and the neutrons makes up what? The nucleus of what? Of the atom. So this is a typical what? This is typical, atomic structure. Then each of the shell represents what? Energy level. Yeah, that's what we call the principal quantum number. So each of the shell represents what? The energy what? Energy level. So the electrons are arranged, around the shell, on the shell, starting from the innermost shell, which represents an energy level, to the what? To the outermost shell. So you start from the innermost shell. The innermost shell has the lowest energy level. Then as you go out, the energy level what? Increases. So energy shells, energy what? Energy level. So look at the subatomic particle. This is the electron. We did the symbol for an electron. The relative mass, I think, is the lightest. Then the charge is what? Negatively charged. This is a neutron. This is the symbol for a neutron. This is the relative mass, and the charge is 0, so it has no charge. This is the proton. Then the symbol is P. Then a relative mass of 1. Then the charge is what? Is positively what? Positively charged. So this is just a brief description of what? The atomic structure. This is representation of the subatomic particles in what? In a table. So it's as simple as what? As A, B, C. So this is a typical examination question that they can ask you based on what you've done. Question. Chemists recognize that atoms are made up of 3 types of particles. Complete the table with their names and what? Properties. Name of particle, relative mass, and relative charge. So it's as simple as what? A, B, C. So please, I want you to attempt this question and feel free to reach out to me if you encounter any difficulty. If you have paid attention to the lecture, I believe you'll be able to answer this question. Yeah, you can see it's 3 marks. So please attempt this question. So I want to look at the behavior of the fundamental particles of an atom in an electric field, the behavior of the subatomic particles in an electric field, the behavior of protons, neutrons, and electrons in an electric field. And we'll talk about a field. A field is a region or space where a force is what? Experienced. We have the electric field, magnetic field, and gravitational field. For example, the Earth is the gravitational field where the force of gravity is what? Experienced. Now, these particles behave quite differently if they are passed through what? An electric field. Protons are positively charged and are attracted to the negative electrodes. Electrons are negatively charged and are attracted to the positive electrodes. And neutrons are what? Undeviated. They are what? They have no charge. So if you look at the diagram before us, you see this is the positive electrode, which is the positive plate. Then electrons are attracted to the positive electrode. Then if you look at the neutrons are what? Undeviated because they have what? They have no charge. The charge is what? 0. Electrons are what? Negatively charged. So you see they are attracted to the positive electrode. Then look at the protons, which are what? Positively charged, are attracted to the what? Negative electrode. So these are the behavior of what? The fundamental particles of an atom, which are protons, neutrons, and electrons in what? In an electric field. So before us is a typical examination question based on what you just treated. If you look at the question, it says what? Beams of protons, neutrons, and electrons behave differently in an electric field due to their different properties. The diagram shows the path of a beam of electrons in an electric field. Add and label lines to represent the paths of beams of protons and neutrons in the same field. So it's as simple as what? ABC, just for you to apply it based on what you've done. And if you have listened attentively, I believe you should be able to answer this question. This is a 3-mark question. So please, I want you to attempt it. And if you encounter any difficulty, please feel free to reach out to me. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Just feel free. So please attempt this question. So we want to look at the concept of mass number and atomic number. Now we'll talk about atomic number. Atomic number is the number of protons in the nucleus of what? An atom. That is the number of protons in the nucleus of an atom is called what? The atomic number. And we use Z. We use the letter Z to represent what? Atomic number in an isotopic what? Symbol. For example, let's say we have an element. This is element X. This element is X. So this is the atomic number. The subscript is the atomic number Z. So we use Z to represent what? The atomic number. Then the next one is the mass number. The mass number is the sum of the number of protons and neutrons in the nucleus of an atom. That is the composition of the nucleus gives us the mass number. The sum of the protons and neutrons in the nucleus. So this is also known as what? The nuclear number. So we use the symbol A in an isotopic symbol to represent what? To represent the mass number, which is the sum of the number of protons plus the number of what? Neutrons. Then we have what we call the number of neutrons. So the number of neutrons is the nuclear number minus the number of protons, or it can also be defined as the mass number minus the atomic number. The mass number minus the atomic number, or the mass number minus the number of protons, or the nuclear what? The nuclear number minus the number of what? The number of protons. So the difference between the mass number and the atomic number gives us what? The number of what? Neutron. Now if you look at the element here, the atomic number is 11. The number of proton is 11. The number of neutron is what? Is 12, which is 23 minus 11. Then the mass number is what? 23. And the number of electrons is also 23 because in the neutral atom, sodium here is a neutral atom. In a neutral atom, the number of protons is equal to the number of what? Electron. So if you can look at the mass number, which is proton plus what? Neutron, and this is the atomic number, which is what? Which is the number of what? Number of proton. So they can give you what? An element, and they'll ask you what? To calculate the atomic number, to calculate the mass number, to tell the number of proton, the number of neutron, the number of what? Electron. So it's as simple as what? As A, B, C. So we're looking at how you can calculate the number of electrons. You know, for a neutral atom, the number of proton is equal to what? The number of what? Electron. When we talk about a neutral atom is an atom without charge. You know, so at that point, the number of proton is equal to the number of electrons. That's why we say every atom has an equal number of protons and electrons. So atoms have no what? Overall charge. That's why I say an atom is said to be what? Electrically neutral, because the number of protons is equal to the number of electrons. But for a charged particle, which is a positively charged particle or a negatively charged particle, how can we calculate what? The number of what? The number of electrons. So for a charged particle, the number for a positively charged particle, which is a cation, a positively charged particle, the number of electrons is equal to what? The number of proton minus the charge, or the atomic number minus what? Minus the charge. Let's take, for example, aluminum ion, this Al3 plus. Here is 13, and here is what? 27. Now you are asked to calculate the number of electrons. In this situation, whereby the number of electrons in aluminum is what? A positively charged particle. Aluminum is positively charged. It has a charge of +3. So at this point, the number of protons is not equal to the number of electrons. Yet the number of protons is 13, but the number of electrons is not 13. So how do we get the number of electrons? The number of electrons is the number of protons. Number of electrons will be equal to number of protons, which is 13, minus the charge. The charge is 3. So 13 minus 3 is equal to what? 10. Therefore, the number of electrons is equal to what? Is equal to 10. So for a positive charged particle, the number of electrons is equal to the number of protons minus the charge, or atomic number minus the charge. Then for a negatively charged particle, which is an anion, the number of electrons is equal to the number of protons plus charge, or the number of what? You know, or the atomic number plus what? Plus the charge. So let's take, for example, we have chlorine 35, which is 17. So you are asked to calculate the number of electrons. Number of electrons here, the number of protons here is not equal to the number of electrons. The number of protons here is 17, but the number of electrons is not 17. So the number of electrons is equal to what? Number of electrons will be equal to what? 17, which is the number of protons, plus what? Plus the charge, which is 1. 17 plus 1 is equal to what? 18. So the number of what? Electron is equal to what? 18. So it's as simple as what? ABC. So before us is a typical examination question. Complete the table to show the composition and identity of some atoms and what? And ions. So I'm just going to solve the first one, and I'll leave the rest for you to attempt. And if you encounter any difficulty, please feel free to reach out to me. So I'm to complete the table now. The name of the element is lithium, which is the first question there, is lithium. Then the number of nucleon number, which is the mass number, is 6. Atomic number is 3. So the number of protons, you have to fill in the number of protons, number of neutrons, and number of what? Electrons. And the overall charge is what? +1. So this is a charged particle. So the number of protons will be equal to what? The number of protons is equal to 3. Because the number of proton is the atomic number. The atomic number is the number of what? Proton. Then the number of neutron is the mass number minus atomic number, which is the nucleon number minus the atomic number, which is 6 minus 3, which is equal to what? 3. But the number of electron, now how do we get the number of electron? The number of electron is the atomic number minus what? Minus the charge. And the charge is what? Plus what? Plus 1. So the number of electrons is the atomic number minus the charge. So what is the atomic number? So to get the number of electrons, the atomic number is 3 and the charge is what? 1. So the number of electrons is equal to what? 2. So here is what? 2. So you can see it's as simple as what? A, B, C. So I want you to what? Complete the rest and feel free to reach out to me. I'm always there for you. I'm Mr. Joseph, your chemistry teacher, in case you encounter any difficulty, and solve as many questions as possible. So this is another example, which is a typical examination question. I'm going to solve A and B, and I'll leave C and D for you to attempt. So deduce the number of electrons in each of these ions. So you have to get the number of electrons. So your number of electrons is equal to what? The atomic number or number of proton minus what? Minus the charge, because this is a positively charged particle. So the atomic number here is 19, and the charge here is what? 1. So 19 minus 1 will be equal to 18. So the number of electrons here is what? 18. Then for B, it's a negatively charged particle. So the number of electrons will be equal to atomic number or number of proton, which is 7 plus the charge, negatively charged. The charge is 3. So 7 plus what? 3 will be equal to what? 10. So the number of electrons here is equal to what? Is equal to 10. So you have to attempt C and what? C and D. As you can see, it's as simple as what? ABC. Attempt it. If you have any difficulty, please reach out to me. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. And please also subscribe to my YouTube channel, comment, like, share, and reach out to me if you encounter any difficulty. I'm Mr. Joseph, your chemistry teacher. Thank you for listening. Thank you. Mr. Joe, your chemistry teacher.